Good morning students. In the previous video, I said that water will have highest specific heat and its value is 1 calorie per gram degree centigrade, and because of this highest specific heat value, it is used as coolant in many of the applications because it will absorb lot of heat energy with very less change in temperature. That is why, because of highest specific heat, and it is absorbing lot of heat energy with very little change in temperature. Because of this reason, it is used as coolant in each and every application. Now I am going to show you practically how it is going to absorb lot of heat energy. So here the things which you require are, so I am taking a candle and I am taking a matchstick and I am going to lit this candle, and I am taking two balloons. First, by using the matchstick, light the candle. Light the candle. By using matchstick, light the candle. And I request you, if you want to try this experiment in your house, please don't try this in indoor, as I am trying this in indoor, because outside there will be lot of air. Candle will not stay in lot of air. That is why I am doing this experiment inside the house, indoor. But I request you not to try this experiment indoor, because in your inside there will be lot of things which can catch fire very easily, like the fridge. Inside the fridge there will be lot of gas which is combustible easily. That is why I request you not to try this experiment in your house. So next, take a balloon and blow it off. See here, I just blew this balloon, and now see, keep this balloon near the candle fire, and it will burst all of a sudden. As soon as you keep it in the candle fire, it will burst.
Ajay.
Okay, please do it daily. Okay, next what you need to do is, again light up the candle. See here, as soon as you keep the balloon near the candle, it just blow off. So now again light the candle. Now take another balloon and first fill it with the water. Inside the balloon, pour some water inside the balloon. In this way, pour some water inside the balloon. Now after pouring water inside the balloon, now try to blow this balloon. Try to blow this balloon. Now I just pour water in this balloon, and after pouring water I just blow it off, and now I am keeping it near the candle fire. So when you keep it near the candle fire, because at the bottom of this balloon, since there is some water, this balloon can withstand. It can withstand.
Show the quantity of water.
See here, inside the balloon there is some water. I think you can observe.
Yeah.
Inside the balloon there is some water. I think you can observe.
Yes, it sounds.
Yes. Now when you keep it near the candle fire, it will absorb. This water will absorb the heat energy, and it will make the balloon not to burst. It means this balloon will not burst. It will sustain for some time without bursting, because all the heat energy released by the candle fire will be absorbed by the water. See here. See, it is sustaining for some time. When I keep it near the candle fire, this balloon still it is not burst, because this heat energy is being absorbed by the water. It will sustain for some time without bursting because water is absorbing all the heat energy released by the candle fire. Still it didn't burst. Still it is sustaining. Wow, this is awesome. Still this balloon is sustaining the fire. Still it is not burst. Let us wait for some more time. See, at the bottom, if you see, this balloon became black. This is the soot. This is the soot of the candle fire. Candle fire, because of the fire, this balloon became black, and all the heat energy is absorbed by the water, and balloon is sustaining the fire. Let us wait for some time. Good, excellent. So around it sustained for 3 to 4 minutes around without bursting. Okay students, now I am going to show you one more example that water absorbs lot of heat energy with very less, that is with very little change in temperature. So for that, again light up the candle. Since it is wet with water, it will take some time. Now, so I am taking two similar 10 rupee notes. I am taking two similar 10 rupee notes. First, two similar 10 rupee notes I am taking. First, one 10 rupee note. If you keep it directly in candle fire, it will burn very easily. If you keep it in candle fire, this 10 rupee note, it will burn very easily. See here, it is burning. This. Now what you need to do is take another 10 rupees note and dip it in water completely. Dip it in water completely. Dip it in water. And now try to burn this 10 rupee note. It will not undergo, it will not catch fire at all. It will not, this note will not burn at all. See here, even though I keep it in candle fire, this 10 rupee note, it is not burning at all. So it is similar to the initial note. So here, why is this happening? This is happening because all the heat energy which is released by candle fire is absorbed by the water itself. So this heat energy is not at all being traveled to the note. This heat energy is absorbed by the water only. So it is not undergoing any burn. This note is not burning at all. So it is as similar to the initial 10 rupee note which we have taken. So here, that is why this is called as unburnable money. So here, this 10 rupee note, this is unburnable note, unburnable money. And you can also do one more thing, that is, if you keep your hand near the fire, oh, it's so hot, it will burn easily, it's so hot, oops, we cannot keep it. Whereas when you wet your hand completely with cold water, if you wet your hand completely with cold water and if you keep it near the fire also, it will not, your hand will not get fire at all. Your hand will not get heated up. Your hand will not heat up at all. So here, still it is not heat. As soon as all the water is evaporated, then your hand will get heat. Your hand will not get heat till the water present on your hand will be evaporated. As soon as water is evaporated, then your hand will catch fire. Thank you for watching the video. If you are interested in order to learn the concepts through these experiments, and if you want still lot of experiments, interesting experiments like this, please join my channel. Thank you.